Good day, viewers. Today we are going to be deliberating on Jacobi method and Gauss method. But before I start, I would like to show us what we need to know, which is very important. Jacobi method and Gauss. Um, if we have a11 x1 plus we have a12 x2 and we have a13 x3 is equal to b1. Then we have again a21 x1 plus a22 x2 plus a23 x3 is equal to b2. Then we have another one, a31 x subscript 1 plus a32 x2 plus a33 x3 is equal to b3. In Jacobi, the reason I'm combining the two methods is that all of them, they have the same the same solving. I will show you the difference between Jacobi, but for now, I want to show you the general methods, the general starting point we need to use when we are solving for Jacobi and the other method that is on the board. We are going to be deliberating on diagonal. What I mean by diagonal is everything that is here is diagonal. From here to here, down here, these are my diagonal. We are going to make use of the diagonal in each of the solving. This is my diagonal in equation 1, equation 2, and equation 3. When I come over to equation 2, I'm to use this as the subject formula. If I come over to equation 3, I'm to use this as the subject formula. But before I use that as the subject formula, I want you to test something. In every equation given, observe before you start solving Jacobi method, you need to observe that since you are picking this one now, that a11 will be greater than the sum of other two. This is what I mean. In Jacobi and this other method, the coefficient here will be greater than addition of the two other here. The same thing applicable here, that the absolute value of the coefficient of this plus a21 plus a23, the coefficient here will be greater than the addition of two other. Then when we enter here, the coefficient and the diagonal here will be a33. It will be greater than the addition of these two other. So it is very important for you to note. It is called diagonal dominant property. These are the properties that you need to note. Very important. The coefficient of here will always be greater than this. The coefficient here will always be greater than the addition of this, and the coefficient here will always be greater than this. And let me make this my subject formula. From here, I will clean this since we are familiar with this now. Making a11 the subject formula we have here to be x1 is equal to, I will transfer these two to the other side. This will be b1 minus a12 x2 minus a13 this. Remember that when the positive change to negative when it crosses the equal to sign. So now making x1 the subject formula, x1 will be equal to 1 all over a11 into b1 minus a12 x2 minus a13 x3. So now remember that I'm dealing with the diagonal now. The next one will be, I'm making this the subject formula. So this will be a22 x2 is equal to b2 minus a21 x1 minus a23 x subscript 3. Now, if I'm to make x2 the subject formula, is to divide both sides by a22. So this is what we have as the subject formula. Now I'm picking this now because I'm dealing with the diagonal. The equation 3 says A33 subscript x3 is equal to b3 minus the two other side a31 x1 minus a32 x2. Now making x3 the subject formula, x3 is equal to 1 all over x33 into b3 minus a31 x1 minus a32 x2. This is the important basic I want you to note for now. This is step 1 when it comes to Jacobi. We want to solve this Jacobi and the other method. These are the important three, making the diagonal the subject formula in each of the equation below. Do well to subscribe to my YouTube channel for more interesting videos. Bye bye.